A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, the instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Our today's lecture will be in continuation to the lecture 5 on bituminous bound courses and their functions under the module 2. In previous lecture, we discussed about bituminous mixes which can be used in base courses, which can be used in binder courses, which can be used in wearing courses. We discussed about the bituminous macadam used in bituminous base courses. We discussed about the dense bituminous macadam which can be used in as a base course also, as a binder course also. Then we discussed about the bituminous concrete mixes which can be again used in a binder course and as well as a wearing course. We discussed about the stone matrix asphalt also, a special mix designed for carrying heavy traffic, especially in case of national highways and expressways. Now today we will be having a discussion on some other types of mixes. One of them is gap graded mix. Now during last lecture we also discussed most of the time we generally focus to make our mixes dense, and that's why dense graded mixes are the most popular one in the construction of flexible pavements. Then there are certain mixes like your stone matrix asphalt or gap graded mix with rubberized bitumen. They have a gap gradation. Some sizes are we skip in those sizes to bring a more stone to stone contact. And the third category was the open graded mixes where you have a relatively very high percentage of voids to serve some particular purpose. So gap graded mix, especially the one which is given by IRCSP 107, which is on guidelines for gap graded wearing course mix with rubberized bitumen or bitumen rubber. Now here this particular mix have gone good trials in India also, along with many other countries, Sweden, South Africa and China, and this have been proven to be a mix with a good rutting and fatigue resistance. And why we are saying that it's a rubberized bitumen, because in this case the bitumen which is to be used here in this one will be a bitumen rubber asphalt, or we will call asphalt rubber binder, which is formulated with rubber from discarded tires, discarded vehicle tires. So we will have crumbs of them of sizes less than 2 mm. And when blended with the hot bitumen, we get our rubberized bitumen. So this is the bitumen which we are going to use in producing these gap graded rubberized bitumen mixes. Now here, since you have a good amount of these crumb rubber particles introduced into your binder, so we will have a high viscosity of this particular binder, and we will be focusing or we will be targeting for at least 20% rubber by weight of bitumen in these rubberized bitumen, so that they will have a viscosity of minimum value of around 1500 centipoise at 177 degrees centigrade. So these will be forming highly viscous binders, and these bitumen rubber mixes, they possess good resistance towards rutting and fatigue cracking, because you have a rubber particles introduced inside it, and to a significantly higher content. So it's a modified one, rubber modified binder. And even these mixes have shown to give good aging resistance, especially that is contributed because in these mixes you give a good film of this rubberized binder over the aggregates, along with whatever carbon black which is present in this rubberized bitumen offers a good protection against UV degradation. So this gives these mixes a good ultraviolet aging resistance also. Now the grading requirements which have been given by IRCSP 107 have been reproduced here. You can see the sizes which are given here, the different sizes which are given here, and the percentage passing, cumulative percentage passing on the individual sizes are mentioned. Now, I will just like to point out, when we discussed about the dense graded mixes, there it was mentioned that around 50% you have coarse aggregates. Coarse aggregates, especially in bituminous mixes or in pavement construction, we consider 2.36 mm sieve as coarse aggregate sieve. So, particles above this sieve are considered as coarse aggregate. Whatever from 2.36 mm to your 75 micron, or I can say 0.075 mm sieve, falls under my category of fine aggregates. So, coarse aggregates are above the one greater than 2.36 mm. Within 2.36 and 75 micron, or I will call it as 0.075 mm sieve, it becomes fine aggregates, and the percentage and the aggregate fraction which mostly passes through 75 micron becomes your fine aggregate. Now, you can see, if you have a conventional dense graded mix, you have around a percentage of say 50 percentage of coarse aggregate and around 43% of your fine aggregate. Now, see what is here. Here this is the range which is passing through 2.36 is 14 to 22. So, here it will be around 18% will be my mid value in that case. So, I will have 82% of aggregate which is greater than 2.36 mm. So, my coarse aggregate is around 82%. And what is my fine aggregate? If this is around 1%, so only 17% of my fine aggregate and around 1% of this one. So, this shows the gap gradation which is created by selecting a particular gradation. We are trying to skip especially the finer parts here, and that makes, and why we are doing it? So as to produce more contacts between the bigger aggregate particles to impart good rutting resistance. So, a gap graded mix with rubberized bitumen is preferably used as a single layer wearing course. It is used mainly for wearing courses of thickness 40 to 50 mm. As I mentioned, this will be the with respect to your NMS, and the NMS is the sieve size where some percentage of material is retained. So, here probably it will be 13.2 mm. So, we normally go for 2.5 to 3 times of NMS as the layer thickness. So, this forms around 40 to 50 mm of the layer thickness. And even this particular one, if an existing surface is there with some minor cracks are there, so in that particular case also we prefer to give it as a wearing course, so that it prevents the cracks to come up in the whatever underlying cracks, they does not reappear on the top course. So, it acts as a reflection crack resistance overlay also. So, and finally, this helps to enhance the pavement's performance and longevity. So, this is a specific like stone matrix asphalt. This is a specific gap graded mix which is gap graded and having rubberized bitumen in it. Now, the other category we discussed dense graded, gap graded, now open graded. One peculiar mix under this particular category is open graded friction courses. Now, the term itself says it is open graded, and friction means it is having some quality which makes it which imparts some more frictional resistance to the surface. So, an open graded friction course is a thin surface layer. Typically, they are constructed in thickness of 1 to 2 inches only, and they are not considered as structural layer. So, my pavement design it will not form a part of my pavement crust, because usually the thickness is around 1 inch. So, the thickness is quite less, that is why they are not considered as a structure component. And they are known by different names also. It is known as permeable asphalt, it is known as porous asphalt, it is known as friction asphalt or friction courses in different parts of the globe. And so, it is usually placed over an existing dense graded or impermeable layer. So, already existing should be a impermeable layer where you place this particular one. And what is that specific purpose because of which these kind of open graded mixes are used? You can see, if I have a layer, existing road surface layer which is impermeable, so it may be any dense graded mix I am constructing, or with if I put a layer of this kind which is having highly permeable or which have a high amount of voids, that is why it is open graded. So, whatever water which comes from the rainwater will go within the layer. Now, what the purpose, how it is designed? So, any rainwater enters into this particular layer, and with the help of camber and cross slope, it moves out to the sides. So, the sides are to be open and the water is to be properly collected from these layers. So, so there will be no movement of water over the surface. Otherwise, conventionally what happens, whatever dense graded mixes we use in a bituminous pavement construction, the rainwater falls over the surface, and with the help of the camber it moves on the pavement surface to the side drains. Here it will move to the sides, but it will move within the layer. So, I will show you how it is. Now, this you can see there are two surfaces. One is a conventional, this upper one is your conventional dense graded surface, and this is an open graded surface. Here on this conventional surface, water is moving with the help of camber to sides. So, you will find some presence of water film over this particular. Whereas, in this other one, this is your open graded friction courses. In this one, water immediately enters into the layer and then it flows within the layer. So, you will not find any water present on the surface. So, similarly, this has been shown by preparing some specimens at the laboratory scale. So, if water falls over this dense kind of surfaces, it moves over the surface only, it does not goes inside the layer, and if it is an open graded, it moves within the layer because it is highly permeable. Now, we have the Indian Codal Guidelines IRC 129, which gives the recommendations regarding the construction, the aggregate, the binder part of OGFC mixes. This is the aggregate gradation. You can see the nominal thickness which is mentioned is around 25 mm. So, typically they are constructed for 1 inch thicknesses, and here they are not considered, as I mentioned, that is why they are not considered as an structural layer, and it allows a quick removal of surface water, and thus surface is able to provide, and since no water film is there, if water is there on the surface, chances of skidding is there because your tire may lose contact with the surface. So, this probability is reduced. This phenomenon where a tire skids because of the presence of water film over the surface is known as hydroplaning, and this phenomenon is significantly reduced in case of these kind of mixes. And here also you can see, I mentioned for dense graded one there was around 50% of coarse and around 45% of fines. Here you will again see this is having a 7.5 say mid range. So, about 92.5 is your coarse aggregates, a very high percentage, and then the other percentage is also very less compared to what we were having in the gap graded. So, this imparts a very high amount of air voids, normally in the range of 20% air voids, 20 to 25% in these kind of mixes. So, here, and why these kind of mixes are preferred or used on some specific places, especially they are preferred when you are having heavy rainfall regions. Now, see, this is an example. This is a 4-lane divided carriageway. You can see this is a 2-lane having a paved shoulder along with. Now, whenever rainfall event is there, water moves with the help of camber, and there may be some minor undulations. So, and since when the pavements becomes more and more wider, water takes time from these median agents to travel to the sides. So, you will always find some film of water existing over it, and when traffic plies over it, you will find a splash and a spray happening when the vehicle tire with the, when any vehicle tire, especially heavy vehicles, if they move at faster speed, a lot of splash and spray is generated, which reduces your visibility specifically. So, if instead of this particular one you go for a surface where it takes water inside the layer, then immediately you will not find any water film over it. So, what the benefit is, it quickly removes the surface water, reduce the chances of hydroplaning and skidding, because if you apply a brake when water film is there on the surface, chances of skidding are very high, and splash and spray, because if you are traveling behind any such vehicle, splash is there, your visibility gets reduced, and this becomes more challenging, especially when you are driving during night times. So, some other salient advantages which normally these kind of mixes offers are, you can see here a heavy vehicle is a good amount of splash and spray is generated, because the water takes time to get removed from the surface, whereas in the other case it just, and when during night time when the water film is there, a lot of glare is also produced, and this presence of water film and glare even brings a challenges to see your pavement markings also or roadside features also. So, the visibility gets impacted when this water film is there. So, you will have, and another important advantage with this kind of mixes is, since they are having a lot of voids in those ones. So, whenever a vehicle tire moves over it, the noise is getting generated with the interaction of vehicle tire with the road surface. This noise gets trapped in these air voids itself. So, otherwise you might have heard about in newspapers the noise barriers need to be installed. You need to have fix up the noise limits, especially in residential areas, hospital areas, educational institutes, because a lot of noise normally comes. A part of that noise is produced from the interaction of your vehicle tire and the road surface. So, that gets significantly reduced because the noise gets trapped at the source itself. So, this is because of this feature, it has been quite popular in some of the countries like Japan, Netherlands, where they use it for especially for noise reduction purposes. So, and we can see it, since this glare is reduced, splash and spray is reduced, so you get a good nighttime visibility, and with this visibility and reduced glare, this road safety significantly improves, and especially under rainfall events or under wet weather conditions where skid resistance is significantly affected. So, these are some typical features of these open graded courses. Now, these are some of the courses which we prefer to use on different kind of national highways, state highways and expressways. Then there are some typical mixes which are often used for low volume roads or for urban sections where you do not experience significant high amount of traffic in terms of the axle loads. So, one of them is your surface dressing. Now, this surface dressing is used as a wearing course for low volume roads, and it has been popular throughout the globe from even from 1920s. In different manners it has been practiced by in different parts of the world. Now, and this provides, what the wonderful part is, it provides a water resistance paved surface for the movement of traffic. See, we discussed in earlier lectures also that entry of water to your pavement structure is can create a significant distress and can reduce the structure integrity of the pavement significantly. So, you want that surface to be water resistance. So, then in that case what is done in this particular one, especially, and that requirement is there, even low volume roads are there or roads having lesser amount of traffic is there. So, it is and known by different names, as in different countries. One common name which have been used for these kind of mixes is chip seals. Now, what is there? It is a combination of a bituminous binder along with it involves an application of bituminous binder along with an application of chips over the surface. You will see, and it has been recommended by, or the guidelines are available by IIT 110 as well as by the rural road manuals. And you can see how the progress have been there in these, specifically in the enhancement on the understanding of these kind of mixes. We in 1965 the first codal specification was there, and presently what we have is IRC 110 2005. So, how the progress have been made in the knowledge enhancement over these kind of mixes. Now, if a single application of this kind of mix is done, how it is done? First of all, you put you can see a prepared surface. If it is a low volume road or rural roads, any other road, you will prepare a base course, a granular base course. Then you put a prime coat over it. We will discuss about prime coat and tech coat at a later stage. At this moment, you can just say, I will put a thin layer of bitumen over a granular course so as to seal the voids. And that makes that surface ready to take up a bituminous layer. So that is what I am doing with the, if it is a granular course, I will put a prime coat and then I will go for a construction of my this surface dressing. If there is a delay between this particular process, laying of a bituminous, I may require to put one more layer of a bitumen, which is normally known as a tack coat. Otherwise, if it follows the construction of the surface dressing, then over the granular course you put the prime coat, allow it to set whatever binder is there, and then you go with your surface dressing course. Here what is done, we put a thick film of it. This is an important, a thick film of bitumen is first sprayed on a compacted granular WBM or WMM layer using a bitumen distributor fitted with nozzles. So what I will do, existing surface has to be prepared, broomed, cleaned in a good manner, and then I will put a thick layer of bitumen over it. After this particular one, stone chips or aggregates are then spread using a mechanized chip spreader, so that there is a uniform distribution of the chips, and even in some cases the chips, stone chips may be pre-coated also or otherwise uncoated also. So I will go for spread of these chips over this binder, thick binder film, and then they are lightly rolled so as only to sit inside that bitumen. Now what is happening, you can see, and this is how the surface looks like. So you will see there is a lot of this texture which is there. These aggregates are more or less single sized aggregates are there. So a lot of texture is created. So it gives a good skid resistance, because water gets when a vehicle tire comes, it gets path to escape between the surface and the vehicle tire. Now what is happening is, I am putting up a bitumen thick film. This good thick film I have put on the surface. Now this thick film will make my surface impermeable, because bitumen definitely, if a layer of bitumen, thick layer of bitumen is applied over any surface, it will make that surface impermeable. Now over that particular one, I am putting up these aggregates, and these aggregate sizes and the binder film are designed or are taken in such a manner that around 3/4 of this particular aggregate gets embedded inside this one. So the aggregates are holded in good manner inside the binder film. Now this aggregates gives you a good wearing surface, wearing course, and this binder which is present is going to give you a good impermeable surface also. So that's why it serves multiple purposes, and again it is not a structural layer, because it is of a very less thickness, maybe around 20 mm only. So why this is, what several benefits we can derive out of these kind of one. It provides a dust free wearing course, because you seal the surface with a thick film of bitumen, especially the whatever normally in rural roads or low volume roads you use waterbound macadam or wet mix macadam. Then it enhances the impermeability of the surface, because a thick film of binder is put over it, offering a riding surface. And as I said, the texture looks, it's an open texture, so it gives a good skid resistance also. And to arrest minor distresses, if some existing bituminous surface is there that is having some minor loss of aggregates, minor cracks, then I can go for this application of surface dressing that will help me to arrest these minor defects in existing bituminous surface, to serve as a renewal coat for periodic maintenance. So this can be done even for urban sections also, for rural sections if I need to, because in urban sections you don't get much damages, much severe rotting, fatigue, cracking, minor defects may be there. So you can put up this as a renewal coat there. So because of this waterproofing and skid resistance capabilities, this surface treatment specifically for low volume roads to medium traffic volume roads is quite popular in India as well as many other countries. As I said, they are known by different names: chip seals, Australia and many other European countries. Now similar to this one, we have another mix which is premix carpet, which is also used on low volume roads or on rural roads, I can say. Now this also have a significant feature, and how this mix is constructed we will discuss about. So it is pre-mix carpet, that means I am mixing something, doing some pre-mixing with this particular one, mainly consists of laying about, now again at 20 mm thick and here it says open graded. Now this is the thing, what gradation I am picking up. Actually I'll be using single sized aggregates, and when single sized aggregates are used, that makes my gradation open. So that's why it is mainly referred as open graded premix carpet. Now when this kind of mix is laid, on the top of it we seal the surface. So we will be doing an application of seal coat to seal the surface, this open graded mix from the top, so that water doesn't enter into it. So this particular one is explained through our IRC 14 2004, the application of premix carpet with the application of your seal coats, and two type of seal coats are explained under this particular. So it consists of constructing an open graded mix using a paving. Now different types of binders are used. Most probably the one preferred are either paving grade, or when we will discuss the characterization of bituminous mixes, we will discuss what are the different types of binder. One is, you can see a binder which needs to be heated up before applying it, so that's a paving grade binder. Other is which doesn't require a heating, which is your bituminous emulsion. So it can be applied at ambient temperatures. Later on we will discuss more during bituminous mix design about what is a bitumen emulsion, what is a paving grade binder, and what is a modified binder. At this moment this is good enough. So I can make an application of bitumen emulsion which at ambient temperatures without heating it. It is because it has low viscosity at ambient temperatures. If I use a paving binder, I have to heat it so that its viscosity gets reduced and I am able to mix it. So then once this open graded mix is laid, it is to be followed with an application of a seal coat. Two types of seal coats are recommended here, a liquid seal coat and a B is a premix seal coat. Now let us see what further. So here you can see this is an application where you are putting an application of the open graded premix surface. Premix coat is getting applied on a rural road. Now the aggregates for premix carpet typically consist of blend of two predominantly size aggregates. One is 13.2 mm, that means it passes through 22.4 and retain on 11.2. So you can see more or less uniform sort of sizes is there, and the other size which is required is 11.2, which means passing through 13.2 and retained on 5. So these two sizes are required which are mentioned here, and the quantities are mentioned in terms of the quantity required for 10 meter square of area. So if a 10 meter square of area is to be constructed, then in that particular case this much meter cube, 0.27 meter cube of aggregate should come up in that particular 10 meter square area of premix carpet laying. And along with it, the aggregate requirement, once that premix carpet is laid, there is a requirement of seal coat. So in seal coat also, the type A which was mentioned as a liquid seal coat, there is again some requirement of aggregate. It says that the coarse aggregates which are to be used are of 6.7 mm sieve size, passing 11.2 and retained on 2.8. And then is premix seal coat, where the aggregates are of smaller sizes and which is passing 2.36 and retained on 180 microns. So this is, and their requirements are again given, and they are also given with respect to the 10 meter square area. So once this surface is laid, on the top of it, to seal the surface, because this is an open graded surface, you need to apply a seal coat so that the words get sealed up. Now as I mentioned, binders, different type of binders can be used. One is the viscosity grade binders which need to be heated up, and modified binder also, but not very popular. Emulsions are popular. So it mentions how much amount of quantity also required. Their aggregate was given in 10 meter square of area, what A size of aggregate is required, what B size of aggregate is required. Then for that A was 13.2 mm NMS and this was 11.2. For those ones they give the required quantity of binder also. It says that you required around 52 kg of binder per meter cube. That means because there we were using the quantities in terms of 0.18 meter cube and 0.09 meter cube. So it says either in 10 meter square area you use 9.5 kg and 5.1. So you be using in that 10 meter square area around 14.6 kg of binder to produce that premix, open graded premix. And once that is laid, Then comes the seal coat. What that liquid seal coat is there, you make an application of binder of around 9.8 kg in 10 meter square area. Once the premix is carpet laying is done, then you spray the binder which is of a quantity of 9.8 kg on the top of it, and you put the chips over it. The chip sizes are already mentioned that this will be in this range. So, this much quantity of stone chips are applied over. So, this is the way you are sealing the surface. The other says that in the other case of seal coat, this fine aggregate is to be mixed up with this much quantity of binder and applied over the surface. So, that seals the surface. So, this is the way we do the premix carpeting and seal the surface. Now, many times a challenge may arrive. Specifically, one has to be very careful when he is applying the seal coat, because if the seal coat application at some moment of time at some places is not properly applied, here you can see this is my seal coat, this is my premix carpet, this is my seal coat. If there is some part where the seal coat application is not very proper or it is not adequate, then the rainwater, surface rainwater may enter inside it. And once it enter inside it, because it is an open graded one, the water will be there within this particular mix itself. And we do not have designed it considering a open graded mix for movement of water to the lateral drains. So, then this water will remain inside this layer. This will damage the underlying layer if it is a bituminous layer or a granular layer, and the layer itself will get damaged. So, the application of seal coat has to be carefully done so as to ensure that the surface becomes impermeable. So, these are some of the mixes which comes under different categories, and we call them as bituminous bound mixes for this particular talk. Thank you so much.